In this video, we're going to introduce ASP.NET Web API. It's incredibly similar to ASP.NET MVC in a lot of ways, and we're going to use it because it's really simple and straightforward to add to our project, and it's going to allow us to expose our endpoints or different specific actions to an API that can be invoked over HTTP, which is exactly what we want. Because remember, the continuous integration server is going to build out our game and our launcher, but it needs to upload it somewhere for that information to be able to be downloaded by our clients. So in order to do that, we need a place or an API endpoint on our website that allows that uploading and downloading to happen. Or rather just the uploading. The files will be accessed directly by the web server. So we just need to do a couple of things to add Web API to our project. First, we go to References, Manage NuGet Packages, and I'm going to add, I'm willing to bet it's probably going to be near the top once NuGet decides to do something. There we go. Oh, there it is. Microsoft ASP.NET Web API 2.1. I wonder if that's indeed the one we want. Let's go ahead and do a search for what was the package name? Microsoft ASP.NET.Web API. Microsoft.ASP.NET.Web API. And that's probably going to be the only one we see. Yep. Okay, so let's go ahead and add this. This will pretty much add all of the code that we need, or all the stuff that we need in the background, but it still will require us to tell the application a little bit about what we've just added. So now that we've added the NuGet references, there's a couple of steps we need to do. First of all, we need to configure the ASP.NET Web API. Fortunately, all that really means is that we need to set up a bunch of routes, just like what we do with ASP.NET. So I'm going to add a new class into our app start. In addition, we need to go into our global ASICs and invoke our code that we're going to add in app start, as well as tell ASP.NET Web API to, well, start working. Remember, we can add all the NuGet packages we want, but they're probably not going to do anything until we invoke it somewhere within code. Let's create that class first. I'm going to go ahead and right-click app start, say add new item, or I'm just going to use ReSharper. Add new class, and I'm going to call this Web API config. The Web API config will be static, just to remind me that I only want static methods on this class. Then I'll have a public static void configure. It's going to take in an HTTP configuration class. The HTTP configuration comes from system web HTTP, and we'll call this configuration. Now, just like what we do with ASP.NET MVC, where we create our default route, like here, where we have our controller action ID, we're going to do the same thing with a Web API. So what I'm going to do is I'm going to say configuration.routes.map HTTP route. The name is going to be API default. The path, or the route template, I guess they're calling it on this one, is going to be API /v1/controller. Then I guess we're going to put in an ID. So we're going to use this just temporarily in order to establish that ASP.NET Web API is working, but we're going to primarily be using attribute-based routing for our controllers, for our API controllers. But for now, this will work. It won't work when we try to add like a version 2 or something to our API. In that case, we're going to need to make sure that we use a different routing strategy. But this is the basic default setup. The other thing that we have to do is make sure that we pass in a constraint or a default of ID equals URL parameter, or URL parameter dot optional, which I believe that's no, it's not. Of course it's not, because For all the similarities between ASP.NET MVC and ASP.NET Web API, there are differences. In this case, URL parameter.optional would be used to define an optional parameter in ASP.NET MVC. In ASP.NET Web API, of course, because they have to be different, it's going to be route parameter.optional. Okay, so now that we've written our configure method, we still haven't actually invoked it from anywhere. Remember, just adding in this class isn't going to do anything because we still need to invoke this class, and we still need to tell our global ASICs about Web API. So let's go down to our global.asics file, and order here is going to be important. We're definitely going to want to register our Web API before we register our ASP.NET MVC routes. So to do that, at the top of our application start, I'm going to say web API config dot register, or sorry, I guess dot configure global configuration dot configuration. So web API config dot configure, and then we pass in our global configuration dot configuration. Oh wow. Web API.config is apparently conflicting with something. That's why I was confused. Web API config is not the class that we want because Microsoft decided to change the way that we configure Web API. Of course they did. Microsoft is very slowly converging all the different ASP.NET stuff into kind of one kind of entity, but that process is a little painful. The syntax that we want in this case is actually global configuration, and this was brought in by System Web HTTP. We want global configuration dot configure, and the global configuration dot configure takes a delegate that allows us to make additional configuration changes to it. Fortunately, we have one of those in our Web API config dot configure method. And since our Web API dot config configure method's signature matches that of the delegate, we're able to pass it in. Okay, the last thing that we got to do before we can test this and see it in action is to create an actual Web API controller. So to do that, we could add these anywhere we want, but I'm going to add them under our controller's namespace, then under another namespace called API.v1. So API.version1. And then inside of this, I will create a new class and I'll call it Test API Controller. Test API Controller will inherit from API Controller. Then inside of this class, we're just simply going to add a method here that starts with get. So I'll say public void get. And actually we'll do public string get. And then I'm going to say return hello world. Okay, so we now have our test API controller being added to our project. Let's come in here and see if our routing works. So I'm going to jump back into the home page of the site after, of course, I did a build. I'm going to wait a year and a half. And then I'm going to do /API/v1/test API. And look at that. We have a string being returned back to us using XML as opposed to JSON or some other format. Okay, but this isn't going to be a very good way of testing our API. What I mean by that is there's going to be a lot of instances where we're going to have to craft specially formed requests to send to our API. And to do that, we either need to create a bunch of HTML forms, which would be silly because Web API is not supposed to be used for that sort of thing, or we use a program that allows us to send handcrafted requests to a API endpoint. Now there's a variety of these programs available for a variety of platforms and browsers. My favorite is a Chrome extension. At least I think it's an extension, or if it's something on the Chrome Web Store, I believe. Actually, let's just see what happens. Yeah, it's on the Chrome Web Store, called Postman. Postman is a very, very, very nice tool that'll allow us to specially craft requests to our website, and it'll allow us to test our API. So I already have Postman installed. I'm going to go into my apps, and I'm going to click on Postman, and I see Postman has been loaded. So let's go ahead and hit this endpoint with Postman. So I'm going to copy this URL and paste it, and I'm going to say send. Now what I get back is actually JSON. So you'll notice that I got XML in the browser, but I got JSON in Postman. That's because Postman isn't sending any headers other than these. Or sorry, these are the return headers. The actual request that Postman is making doesn't send any headers. If we look at the headers that are sent by our browser, by going to our network tab and looking at our headers, we see that we have a accept header of text HTML, application XHTML plus XML, application XML, and a bunch of other stuff. That's because the way WebAPI works is it negotiates the content type, whether that be XML or JSON, via the accept header. I can show you guys an example of that by coming over into Postman and clicking on headers and adding a new header called accept, and then let's set it to application XML and see what happens. If I hit send, now notice I get my XML back to me. Well, obviously this isn't what it doesn't really matter. The content negotiation doesn't matter so much, except in instances where we try to serialize an object that can't be serialized using the default XML serializer. We're going to primarily be using, or probably exclusively be using, JSON as our format for both posting data to our API as well as retrieving data from our API. Okay, so instead of application XML, we are always going to be setting our accept header to application/JSON, which returns the data in a JSON string. I'll show you guys an example of where returning XML wouldn't work. If I come back here and I change my method, my get method, to return an object, and I return an anonymous object, let's say test equals blah, and then whoa equals new array of 1, 2, 3, 4, 5, and then recompile this. If I come back to Postman and I have my accept header set to application JSON and I hit request, notice how I get this object back to me in JSON. But if I change this to application XML, I get an error. It says an error has occurred. Type failed to serialize the response body of content type application XML. Type anonymous type cannot be serialized. Consider marking it with the data contract attribute and marking all of its members you want serialized with the data member attribute. So yeah, that means that our XML formatter isn't intelligent enough to, or isn't designed. I shouldn't say it's not intelligent enough, but it isn't designed to be worked with using unannotated classes, especially as in the form of anonymous objects, because I want to be able to take advantage of anonymous objects as well as classes that haven't been annotated with special attributes. I'm primarily going to be, or exclusively going to be, using application JSON as my accept header. Okay, so now we have that all done. Let's go ahead and take a look at attribute-based routing. So instead of routing with our route that we saw before, where we mapped the route, I want to go ahead and route each one of our controller actions with a specific path. That'll allow me to control the versioning of my API, as well as more fine-tune the different paths that I might want in my controllers. So first of all, we'll be deleting our test API controller, and we'll be creating our first real controller in our API v1 namespace. So let's delete that test API controller. To use attribute-based mapping, or attribute-based routing, instead of doing configuration routes map HTTP route like this, which is explicit routing, I'll go ahead and comment that out. We're going to instead do configuration dot map HTTP attribute routes. So by doing this, it's going to search our assembly for our controllers, and it's going to search our controllers for methods that are marked up with particular attributes, and it's going to use that information to give us our routes. So let's go ahead and create our first real our API controller. We're going to create our launcher controller, which is going to be responsible for querying against the latest launcher versions, as well as uploading new launchers to the site. Now in this video, we're just going to be stubbing out a couple of these controllers that we're going to be working with and making sure that they work properly, or at least they get mapped properly. In the next video, we'll actually go ahead and look at hooking these guys up. So I need to make this class inherit from API controller first of all. Then I want to make a method public. Let's just say object for now. We'll change this return type later. I'll say public object get latest launcher. And this is going to return a new object. Let's say that, and this is just all garbage data. Again, I'm stubbing out the methods. So we're going to say new, and then version is going to be 5, and then we'll say URL will equal blah. I mean, it's irrelevant what this returns. The point of what I want to show you guys, though, is how we can use attribute-based mapping to map this up. So what I'm going to do is I'm going to use the route attribute. The route attribute is what we use to add in our attribute-based routing. So in addition to the route attribute on our get latest launcher, we could say /API /v1 /launchers /latest. So that could be our API endpoint for our version 1 launchers latest. There's an easier way to do this though, because if we created another route, like for example, public void upload launcher, which returns nothing, we would have to say route is API v1 launchers upload. Notice how I'm redundantly adding this API /API /v1 /launchers. I can get rid of that redundancy by adding another attribute to my launcher controller itself called route prefix. And then I can simply write API v1 launchers, and then I'll just have this be latest, and then this be upload. Okay, there's one more issue with our launcher controller, and that is we haven't specified to WebAPI which HTTP verbs should correspond to which actions. For example, my upload launcher, I want it to only respond to post requests, whereas my get latest launcher, I only want it to respond to get requests. To do that, we just throw on some more attributes. So this one is going to be HTTP get, and this one is going to be HTTP post. So now we've specified that this method is only invoked when this URL is hit with HTTP get, and this method is only invoked when this URL with HTTP post is hit. Let's hit F6 and see if our attribute-based mapping is working. I'm going to come over here and pull over Postman, and instead of hitting our API v1 test API, I'm going to be hitting API v1 launchers latest with get. And of course, I'm going to be sending my accept header. Okay, the route template blah 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 and the action name blah cannot start with the / character. So the problem is that we don't want this / here. Whoops, I just slightly overlooked that, but get rid of that / and then hit send. Yay for error messages that tell you how to fix things. All right, so we see that we get this data back, which is what we want. Let's go ahead and change this to a post request and hit send. Then we get a message back saying the requested resource does not support the HTTP method post, which is exactly what we want as well. Now let's try our upload. We should be able to post to upload by hitting send, and we get nothing back, but nothing is a good thing. We didn't get any errors back, which means that it properly hit that. But if I set this to get, you'll see that it says the requested resource does not support the HTTP method get. Okay, so that's basically the introduction to how we can expose our Web API. This is, of course, not a comprehensive introduction to Web API. If you guys want such a thing, I wouldn't be unwilling to put one together. I just wanted to go ahead and stub out our launcher. We can go ahead and stub out our client controller and our credentials controller as well. And also, let's go ahead and also add in our authentication with our tokens, because that'll be really cool. So let's first step out our client. So we'll do client controller. Our client controller will inherit from API controller. It'll have a route prefix of API v1 clients. It'll have a couple actions: public option object get latest client, which will have a route of latest, which will return a new empty anonymous object for now. Then we're going to have a public void upload client, which will be a route of upload. And then we need our HTTP verb of post, and then our get latest client will have an HTTP get as a verb. So now we have our client controller and our launcher controller. Let's go ahead and do our authentication controller. Our authentication controller will inherit from API controller. It'll have a route prefix of API v1. Oh, come on. Come on. Why can't I hit the V key? API v1 authentication. It'll have a couple of different methods. We'll have a public Boolean validate credentials, string username, string password, which will simply return false. This will validate that a user does exist in our database. And of course, I'll give this a route of validate with a HTTP post as the action. Then we'll have a route login action with HTTP post, and it'll have public object, let's call this login. Or you know what, let's call this generate token. The method name. I'm going to leave the object or the route name as login. Okay, so these are going to be our three primary API controllers. One for the launcher, one for the client, and one for the user being able to log in. But I really want to lock down the upload client method and the upload launcher method, because I really don't want people who are unauthorized to be replacing our client or our launcher, because that would pose a significant security risk that I'm not very keen on doing. So what we're going to do is we're going to put together a filter, an action filter in the form of an attribute that we can then use to add additional behavior to our action. In the case of our system, we're going to verify the existence of a token header that is a valid header and that is being sent from the valid IP address. So let's go ahead and do that. All it's going to require us to do is to create a new class that inherits from action filter attribute. So I'm going to do that in my infrastructure namespace, and I'm going to name this authorize deploy token attribute. The authorize deploy token attribute will inherit from action filter attribute. It's important, though, that I inherit from action filter attribute in system web HTTP filters and not in system web MVC, as this is going to be a web API action filter and not an MVC action filter. Next up, I want to do a public override on action executing. Now, on action executing gets invoked before whatever attribute or whatever action I annotated with this attribute is invoked on. Okay, so I'll delete the code that comes in there by default. Now, the first thing I want to do is say something. What do I want to do? First of all, let's go ahead and get that header. So I'll say action context.request.headers, and then I'll do, is there a try get? Yeah, try get value, or let's try get values. let's just do get values, I guess, token, or how about deploy token? And then I'll do first or default. I'll say var token equals. Then I'll say if string.is null or whitespace token, then they're an invalid request. So I'm going to say action context dot response, and then I'm going to basically want to override the response. To do that, I can simply set the error result on the context. So I am so used to MVC. there's going to be oh great, it's not even there, is it? Response error. Let's see here. What can we do? We have request context, response, action descriptor, controller context, and action arguments. Let's see about getting that. I guess what we can do is we can just replace the response entirely. So let's go ahead and say response equals generate not authorized response with deploy token header is not present, and then return. So I'm going to write this method generate not authorized response, and the reason I'm doing that is there are a bunch of different conditions in which the person won't be authorized to access this particular resource. And so to keep the code clean and to remove the levels of indentation, I want an early exit. But because I'm going to be reusing this a bunch of times, I'll turn it into a method. So that's simply going to create a method that says HTTP response message generate not authorized response, and then the string is going to be message. It's simply going to return a new HTTP response message with an HTTP status code of not authorized, or unauthorized is the proper status code. And then I'm going to set the content to equal new. Let's pass a new object content. Or that's not going to work because it wants a type. Let's pass a new. Let's just pass a new string content. And then what I'm going to do is I'm just going to serialize down. Or no, I'm just going to print out the message directly. It's easy enough. Okay, so that's our generate not authorized response method. Okay, so we've now established that we have a token. So let's go ahead and open up a connection to our database. So var database equals new MMO database context. And then we'll say var deploy token equals database dot tokens dot single or default. Oh, come on. Single or default, which will require system.link at the top. T goes into T token equals token. Then we'll say if deploy token equals null, or deploy token dot IP address does not equal action context dot request dot oh, come on. Let's see here. It looks like HTTP request message is a little bit different than the HTTP context that I'm used to working with. So to fix that, I'm just going to extract the HTTP context directly from our action context. This is going to make it so that you won't be able to host this code inside of a web server that isn't IIS. But since we are using ASP.NET MVC already, that's already a given. We're going to have to be using IIS or the mono implementation of it. So let's go ahead and grab that HTTP context. I'm going to say var HTTP context equals action context. Then I'm going to do request dot properties. And then I'm going to grab it out of it. So I'm going to do HTTP context wrapper as a cast. Properties ms.html HTTP context. Of course, this is going to require that I bring in system.web. Okay, I now have my HTTP context. Let's go ahead and get that IP address. So HTTP context dot request dot, oh great. Did they change this again? It's going to be the remote. We want the user host address. And finally, I know how to do this stuff, guys, I promise. Alrighty. And that pretty much wraps up our authorized deploy token. We make sure that the deploy token header exists. We then query the database to make sure it's there. We then validate the IP address. So now all we have to do is add this authorized deploy token attribute to our methods that we want to secure, and then we got to test it. So let's start with the client controller and look at the upload client action. So what we need here is authorize deploy token, which is going to bring in system or BuzzMMO web infrastructure. Next up, we go to our launcher controller, find the upload launcher method, and say authorize deploy token, which of course brings in BuzzMMO web infrastructure. Now that we've done that, I can come back to my Postman and I can try to hit launcher's upload. Well, of course I have to recompile, so I hit F6. And then I hit send, and I should get an error saying my deploy token is not in my headers. Oh, come on. What did I mess up? Oh, I added this this trailing slash to everything. So I need to remove this from the client controller, and I need to remove this from the authentication controller. To be fair, I haven't used WebAPI a whole lot. It is an appropriate bit of technology for what we're doing with an API that we're putting on the web. And actually already I see it's a lot cleaner than what I would have to do with the corresponding MVC code. But again, there's a little bit of a learning curve with it, especially since it's so similar yet so different from MVC. Okay, I get a message, an error has occurred. The given header was not found. Another learning experience for me. The getValues method on our request headers throws an exception if it wasn't found. So that means instead of using getValues, we're going to have to use tryGetValues. So to do that, I'm going to write an IEnumerable of string called token header values, and then I'm going to say action context dot request dot headers dot tryGetValues, name of deploy token, out token header values. And then I'm going to say var token equals token header values dot first or default. Let's see if it sets token header values to null if it can't find tryGetValues. So let's go ahead and hit F12 on that line of code, and we'll have ReSharper decompile it for us. Okay, so it is going to set our IEnumerable to null if it wasn't found, which means I have to organize this code a little bit differently. I'm going to take token and I'm going to put it underneath the if statement. Then I'm going to take this code and I'm going to place it inside of the if statement and negate it. So what did I just do? Well, the return value of this tryGetValues is we're going to return false if the token wasn't found, or if the header wasn't found. And it'll set token header values to null. Unfortunately, by setting token header values to null means I won't be able to invoke first or default on it. So I have to take the code that invokes first or default, and I have to place it underneath the if statement. Let's hope that was the last thing I had to learn about WebAPI in order to get this stuff to work. Yay, deploy token header not present. All right, let's fill in our deploy token header with some garbage. Invalid deploy token, nice. Now let's jump into our admin, and I want to generate a deploy token that is an IP address that I won't have. So I'll say create token, and then I'll just put in some garbage. That isn't close to being a valid looking IP address. That's better, whatever. Okay, so here's my ridiculous IP address that I added. I'm going to double click this token and copy it. I'm going to go back to Postman, and I'm going to set that as my deploy token. Unfortunately, I don't think that copied the whole thing. There, now it copied the whole thing. Now I'm going to hit send, and I get invalid deploy token. In this case, I get invalid deploy token because my IP address did not match that of what I had on the database. So now let's try a deploy token that is of the correct IP address. So I'm going to come in here, paste it in, hit send, and I still get invalid deploy token. Likely what's happening is my IP address is being changed to something different. It might be my external IP address. So to test that, I'm going to set a breakpoint right here in our code, and I'm going to hit F5 to launch debugging mode. I'm going to wait a year and a half. All right, then I'm going to come back to Postman, and I'm going to retry that request. Okay, so let's see if we do get our deploy token. Now our user host address, oh god, this is a cruel joke. Our user host address is the IPv6 version of our IP address. Well, this is going to be fun. Especially since IPv6 can be expressed in so many different ways. I'm going to have to revisit the logic that checks my IP addresses because it's going to have to be a little bit more complicated than what I'm doing right here. But I guess what we can go ahead and do is simply use IPv6 addresses inside of our deploy tokens. So let's do that. I'm going to create a token, and I'm going to say : 1, which is the local host for IPv6. I'm going to create that token. I'm going to take this token, I'm going to paste it into Postman, and I'm going to hit send, and look at that. I don't get an error. Because I don't get an error, that indicates that we indeed got all the way to our action by passing in our appropriate deploy token. Alright, sorry guys, that was a bit of an adventure for me as well, but in the end, we now have our API stubbed out, we have our deploy token set up properly so that we can lock down and secure our continuous integration server, at least the endpoints that it'll use, and we've tested it with Postman. So I think that pretty much wraps this video up, and we'll see you guys in the next one.